Let me check the recording. Recording is up. Okay. So I'm going to write this down into Moodle, so that way it is going to be a part of the the notes here. Okay. So the solution is okay. Let me see if I can do this equation editor thing. Let's see, where is it? There we go. I'm faster without using the equation editor, but the nice thing about the equation editor is you can preview it as you type. So that's the only part that is nice about it. Okay, so we have basically f, oh, can't see that part. There we go. So we have f of x, y, and then whole thing z is the answer to the first part. Okay. In other words, okay, let me just do this part here. F3 and little inverse thing here of x. Oops, not inverse, not yet. Do it later. There we go. So the bottom part is what you probably want to look at. Instead of looking at how I type it, it's the bottom part that is the actual answer. Are there any questions about this? Now, this is not the only way to do it. There are several ways to do it.
So they have to be the same function after that?
There are 6 ways to do this. Okay. Well, not 6. I think there are 3. 1, 2, 3, 4, 5, 6. There are 6 ways to do it.
Well, what I mean, could be a different function.
Different function?
Inside.
Inside?
Yeah, another function that maps to 2.
Is it injected?
It's just a notation.
Just a notation?
Yeah.
Okay, so it's a notation of which function?
So like you see how f, and you give it the first parameter, which is a function itself, or return the second. Now the inside is the g function that maps to n or n by n to n.
But what is g then? Do you define g?
Yeah. This is a special case. I'll be doing with more general.
Okay. Well, I guess when I read your submission, I'll then see what you actually have. Okay. All right. So, any questions about this one? No questions about this one? Okay. What about the inverse? Now, assuming this is how I derive F3, how do we look at the inverse? So the one thing we have to do, okay, I'll use a comma here to separate the two definitions. So F3, F subscript 3, superscript -1 for the inverse. The inverse only takes one single natural number, but then it has to somehow split it into 3. So we'll just go ahead and say it takes in I as a natural number. That's the parameter. We wanted to split into a 3 tuple. In other words, we already know what it looks like. Okay, we know it's going to be a 3 tuple, and we just have to figure out, okay, what are the components of the 3 tuple? It has to do with how we combine in the first place. So we have to basically reverse it first. So the first thing that we do is we split it into fx, y, and z. Okay, the first split is going to split into that. So z will be the immediate answer, but x, y won't be the immediate answer because they need to be split again, or they need to be split again. Okay, so we'll deal with z first. Z is the easier one. So z is going to be f inversed, because we are just reapplying what we have already defined, which is the inverse function of f, applied to the only argument, the only thing that we know is I, but that will give us 2 numbers, okay? And we need the second part of it, and according to my notes, square bracket 1 will get us the second component, because square bracket 0 gets us the first component. This will get us the second component. Are we doing okay so far with this part? Okay. What about x and y? Well, x and y both will have to do something about this part. So I'm not going to write out the answer, just spell it out. But we know both of those will have to do something about that, because that's the one component that we have not used yet. Okay, we use the other component as the z, so the xy will have to be based on this. But this component, according to how we combined x and y into one number before we fed into the second function f, this component has to be split. How do we split it? F inverse again. Yep, exactly. So we just have to apply f inverse again. Okay, I know this is going to look ugly because it's going to push it out of the screen, but it actually does turn out to be the right thing to do because. Okay, so this will give us two numbers, and we only need the first one in this case. The second one is going to be f inverse applied to this whole thing, and then we take the second component as a result. So let me shrink the screen a little bit, or let me see if I can split it into two lines. I think that might split it into two lines. There we go, much better. Is that okay? I know it looks like a big mess because it is kind of a big mess, but the notation helps to identify, okay, what are we doing? Are there any questions? As I said, do not use something over something, squares, square roots, and that sort of thing. Yep.
Is it imperative that the numbers be in that order, or can we?
No, you can reorder. There are 6 ways to do it.
Okay.
Yeah, there are 6 ways to do it. It's just that your F3 has to be consistent with your F3 inverse. So however you combine the number, it has to be the way you split the numbers.
Okay.
So that's the only part that has to be self-consistent. Okay, any other questions? Yep.
If you don't exactly write it like that, is that necessarily wrong?
Sorry?
If we don't write it exactly like that?
Well, it depends on how it is not exactly like that. If you split it a different way, if you combine, let's say, y and z first.
We did a function, the function inverse of the second function.
Say again?
So I gave function 3 equals that. We did the inverse of the second function.
Okay, I'll have to actually read your answer to give you an idea. All right, so that's the answer. I'm going to save my question because it is now a part of it. Okay, do I have to do anything to get out of the equation editor? Just click Save Equation, I guess. And now it is a part of the homework description. Just have to save this again. And then the solution is now a part of it. Cool. Any questions? Are there any questions about the answer, which is very clean? Just reformat it here. No questions? Yep.
Did you also have to define the third function?
Say again?
Do we have to define the third function?
Which one?
The f of 3 x, y, z.
That's part of what I'm asking.
Okay.
Is right here. You will find a bijective function f3. So yes, you have to define what f3 is. Yep.
The way you presented it in the description, it was functional of I, and the way you typed the answer was the function of a function. So, is the answer in terms of I will be accepted as well?
You mean the inverse?
Yeah, like I see the way you give it an example.
Yeah.
In terms of I, and then on the bottom you have just like function.
No. That's not true. This is one chunk. This is the first chunk. There's a comma here to separate the second chunk, and then there's a comma to separate the third chunk. Did I get the parentheses messed up? No, they look right to me. No, there are still 3 components. I'm still specifying a 3 tuple. It's just that each tuple is kind of long. Yep.
Is it okay if I separated out the 3 tuple using the indexing notation?
Separating the
Of the inverse, the 3, so I instead of writing it out in parentheses, I just used the notation another time and said
Okay, I have to read it because I'm really poor at forming a mental picture, but people just tell me what it looks like. So I have to actually read your submission before I can determine that. Okay. All right. Any concept problems with concept issues or concept questions? No concept questions. Okay. Yep.
Can we draw it now? We were allowed to draw before, but can we draw it now?
It's pretty hard to draw it out. I mean, you can do the computation. You can punch in the equations into a spreadsheet and have a spreadsheet to give you the actual numbers. But it's not going to be very easy to draw it out. Because the way it folds a two-dimensional space into one is going like this. So when you look at a single number line, it's not going to be, it will be jumping all over the place. So it doesn't look like there's any pattern to it when you look at it, when you look at the 3D thing. Yep.
Can I get extra credit if I draw on the board?
You actually thought about
Okay,
it.
we can use a spreadsheet to do it. I mean, that's the easiest way to do it, right? Okay, so which way do you want to map? Do you want, okay, well, I guess, looking at one is going to be enough because the other one is just reapplying it. Okay, so let's do it. Getting back to the reading material first, because I don't think the visualization is going to help much, but we can always just give it a try. All right, so the equation, the closed form is here. Okay, this is the only function that we need to define, and then we need to use a spreadsheet to do it to the first, fold 2D space into one, and then fold the other one into the last one. So that's, well, I can give it a try. And let's start a new one. Not everything can be visualized. Just keep in mind that not everything can be visualized. Okay. Let's see. So we have 0, 1, 2, 3. So let's try to do a 4x4. Okay. Any questions?
4x4 what?
We'll do a 4x4 cube. Okay. Figure out the values of those. That may be a little bit too ambitious, but we'll see. Okay, so we have x going this way, y going this way. And the equation specifies x plus y times x plus y plus 1, the whole thing divided by 2 plus y. Okay, so this will become, open paren, this number plus this number times, oops, need to specify the times here, oops. In parentheses, this number times this number plus 1. Oh, those are pluses, not times. Okay, go back here. There we go. The whole thing divided by 2 plus y, which is just this one. Okay, so now I can just do it like this and do it like that. Okay, does it work? Nope, does not work.
Did you divide by 2?
Sorry?
Did you divide by 2? I don't.
Yeah.
It's going to divide your last element,
Right.
not the entire.
No, it's not referring to the right. I need to lock down the row number for. Okay, this is B1. Okay, for the B, I have to lock down the row number.
Yeah.
So have to lock down this part. And then for the A, I have to lock down the column number. So the A has to have a $sign on top of that.
Is the dollar sign supposed to be before the B? Or in
Yeah, the
between?
$sign means absolute.
Well, what I'm
Otherwise,
saying is
it gets
you have-
copied.
You
Huh?
have it in between the B and the 1, as opposed to before.
Okay.
Yeah, its position, I think, changes what it does.
There we go. I think that works, right? 0, 1, 2, 3, 4, 5. And it was 6. Oh, 6 is supposed to be over there, so it does work. Because 6 is supposed to be here. 7, 8, 9, and 10, 11, 12, 13. So it does work. Okay. So are we doing okay so far with this part? Now, once we have this part here, the next one is going to be on the next sheet. It's going to be based on what we have here. but we have to look at these numbers. We are mapping x, y into a w. So these are the w values. And then we map the w values into, okay. So now we have to look at a 3D thing. Let me see how we can do a 3D thing here. Yep.
So I'm not sure if this is the right way to do it, but I just used 2 separate copies of that and then referred to the next one. So like I made one with x and y, and then I made the other one with z and f of x and y.
You can have f of x, y. Okay, now that we know what is f of x, y, we can now just use z, and then the x, y. Okay, I got it. Okay. So at the on sheet 1, I'm going to relabel it as f of just x, y. Ah.
No mic. No mic.
Oh. No
For
mic.
people to listen over there.
Oh, do you guys want to use the mic here?
So
Yes? No?
it works better
Those
with
of
the
you guys
recording. Like when you're over there and then the mic's on, you can actually, the recorder works better that way.
Which is interesting because your ear, when you're in class, you can still hear me kind of the same way, but once it's recorded by the mic, it doesn't sound the same anymore. What is that suggesting?
You might be a Martian, right?
No, you guys are Martians. No, I think what's happening is when you're in class and you can actually see me, when I walk, you can gauge the distance between you and me, right? So when I'm further away, I think your brain automatically cranks up an internal amplifier.
That's a lot of math.
So that the volume of my voice will still sound kind of the same. Think about it this way: if you cannot see me, if there's a veil or something behind this, okay, and I walk around, and for some of these people here, it will sound softer and so on. You will start to notice, right? You will start to notice the difference. But when you're here, you can actually see me. You don't seem to notice. Oh, you're too far away. I can't really hear you anymore. I think that's because you can actually estimate. You know that I'm walking away further, and your brain is already making adjustments for that. Or your expectation is that it's going to be softer, so that part does not surprise you. But when you're watching the video, you don't see me, anywhere, and your brain, keeps the expectation of I want the same volume. I want the same volume, and when it changes, your brain is confused. It's like, why?
So
Well, because he's walking away, but I don't see him walking away, so that's why.
would a bi-directional mic change that? Like
What?
if you had a mic that picked up instead of in one direction?
That I don't know, but I think what may help is a little distance meter between me and the
Yeah.
mic.
Yeah,
That is actually displayed on screen, so you can actually see the distance between me and the
That would
mic
help.
when you're watching the video.
Well, you wouldn't need that. The mic would just use that distance to like.
Or you have a wireless mic, fixes all the problems.
Yeah, but it'd eventually reach a point where
He
it could
does
hear
have a
us
wireless
breathing.
mic. He's
It
got a
is a
wireless
wireless.
mic on right now.
Oh, that, okay.
I'm talking about the mic that records for the videos,
You're an idiot.
obviously.
Well, if he used such a device to record for the video.
Okay, so this is what we'll do. Okay, so on the first sheet, I guess some people cannot read it down here. So on the first sheet, I label it as f x y, and then on the second sheet it is f of, and then the first component is f x y, and then the second component is the z is a 0. Okay, so this way I can plug in the values of the first one into the second one. Is that making any sense? Sort of. Okay. All right, so we'll go ahead and, but how do we pull these values out of this one? Because there are several ways to, oh, okay, I know it. Okay. All right, so this will still be 0, 1, 2, 3. And then on the other side, we still have 0, 1, 2, 3. Okay. So the value of this cell is going to be the equation applied to a cell of the previous sheet and 0. Okay? So now we specify it's going to be this number plus 0. Yep, okay. plus 0 plus, okay, that's it for the first one, times the same number plus 0 plus 1, the whole thing divided by 2, and then plus the y itself, and the y is still this guy here. Okay. And then we have to go back and fix a few things because we don't want some of the references to change when we move the cell. So the B has to be locked down by row, and then the A has to be locked down by the column. There we go. All right, so let's see whether that works or not. Nope, I can see it's not working because it's supposed to be an injective function. I cannot see 2 zeros. Okay. Why would that be a 0? Yep. Oh, because I forgot to do this part here. Clerical error, sorry. There we go. All right. Is that working? No, no, that doesn't look right to me.
Come on, Jack, you can do it.
Yep.
I don't agree with the last one, but I think it's the B and Z as opposed to the Y. I could be wrong.
Okay. I think I should not be locking down. Okay, I think the problem is I should not be locking down the column and the row numbers, because I am actually referring back to a particular cell in the first sheet, except for the last one. The Y does need to be locked down. Okay, let's see. I think that looks right to me. Okay, let's figure it out. Okay, how do we test whether this works or not? Pick a particular one. Pick this guy. So, okay, what is this supposed to be? We'll do it on the whiteboard.
Is it I?
Okay, this is supposed to be f of, and it is x is a 1, y is a 2, and then on top of this, the z is supposed to be a 0. F of 1 of 2, we have already figured it out. So we'll just go back and refer to that number. So this is 1, 2, so it's 8. So we have 8 plus 1, the whole thing divided by 2 plus y, and y is actually, oh, it's z this time. Okay, because that's my confusion. Okay, so that's because this one is supposed to be just 0 in this case. So let's go ahead and redo this. Cross check. No, that doesn't look right.
We're still on f of xy. We're on f of xy.
Oh,
Yeah.
okay.
So might want to control Z that.
Undo twice. Wrong sheet. Okay, so with this one, okay, that's the last one. The last component is wrong. So plus z, which is the 0 in this case. There we go. Okay, so is it working out? The cell that we were looking at is this one. So we have 4 times 9 is 36. So it does work. So if you want to do this one more time, we can go to sheet 3. It gets easier. Because this one is just f of xy, okay, and then comma 1. So z is basically 1 in this case. And I don't know whether we can just copy and paste it and change that 1, because I'm not sure whether the sheet reference is also floating.
Should.
And in this case, the sheet reference is floating, which is not what I want, right? Because I always want to refer to the first sheet. which is okay, because I can just change the name of it itself. There we go. And because Z is a 1 this time, so we have a 1 here, and we also have a 1 here. Nope, that doesn't work. All right, why did I mess up this time? Hmm? Oh, this one is +1. Thank you. Okay, compared to this one, yep, I think that works. So now you can make up these things and then just kind of stack them up, and then you can look at 3 layers or 4 layers, and then see if you can find a pattern. Did you see a pattern since you have done it already?
I didn't do it that way.
Oh, you didn't do it that way? Okay. Alrighty. You do see a pattern?
No, I said
Okay. Well, this is with 0, this is with 1. And the best way to do it is to really dedicate, well, if I were to do this, if I planned ahead of time and actually did this in a different way, I would have done it in a slightly different setup as a spreadsheet. But this is okay, it still kind of gives you an idea of how to do it. All right, any other questions? No other questions? Okay. If there are no questions about this, I'm going to move on and continue to talk about propositional logic or propositional calculus. How many people did find some time to read about propositional logic? Okay, very good. We talked about the why already, and we already revisited all the basic logical operators. We added 2 more. One is implied, one is equivalent to. And now we are on to propositional calculus. I gave you a definition. Last time we talked about alpha. Alpha is a set of the alphabets, basically, the most elemental elements of a propositional logic system. Omega are the connectives. They're basically operators. And then we talked about what is a well-formed formula. A well-formed formula is basically things they can make out of elements of A, the alphabet, and also the connectives. But if you have a connective that expects 2 arguments, you have to supply both arguments. And you can combine well-formed formulae by connectives also, and those become basically bigger well-formed formulae. So that's basically the idea of a well-formed formula. Are there any questions? Yep, go ahead.
So in omega goes your operators, your connectives. Do well-formed formula also go in there?
Say that again?
Do well-formed formula go in omega?
No.
Okay.
Well-formed formula are the things that we want to work with. So at the lowest level, we have the alphabet. Okay, so in this case, I use 0 to mean false. I use 1 to mean true, and then you can have the variables P, Q, R, and so on. And then we have the Greek symbols P, Q, R. So P, Q, R, each one is called a variable, which means it can be a 0 or a 1. It can be one of the constants. Okay. And then we have the Greek symbols. The Greek symbols, we have phi, psi, rho is looks like a P. It's like that. Yeah. So we have these, each one can be a well-formed formula. Okay, they match a well-formed formula. And then we have the operators, right? So we have the operators. So the logical operators consist of and, or, not, imply, and also equivalent to. So these are the things that we have talked about. This stuff here is in the alpha set. This stuff here is in the omega set. The well-formed formula, they're not in either of these sets. They're basically sentences that you can form using the alphabet and also the connectors. Okay? So using only this particular set, you can basically say, well, I can form something that may not be very useful. Okay? I can say P and P. Is that a well-formed formula? Yes, because P itself is already a well-formed formula because it is from alpha. That's by definition, it is already a WFF. Anything, if you have a WFF on one side, WFF on the other side, and this is a omega 2 element, which is an AND, the AND is a part of that set, this by itself is also a well-formed formula. But because this is a well-formed formula, you can also use it to combine with something else, like put a negation in front of it. That becomes a well-formed formula. Are we doing okay so far with this? Yep.
So you say a letter by itself is already well formed?
Yes.
Formula?
So are constants. 0 is a well-formed formula. 1 is a well-formed formula. P, Q, R, each one is a well-formed formula.
Whatever is in alpha?
Yes, whatever each element in alpha is already a well-formed formula. But elements in omega are not well-formed formula because they're connectors. They need to be connected to well-formed formulae in order for the whole thing to be a well-formed formula.
Thank you.
Sure. Yep.
So just to be clear, if you did a well-formed formula in the or with a non-well-formed formula, would that be a non-well-formed formula?
That is correct.
Okay.
So if you have, a non-well-formed formula can be just a symbol by itself, right? So this would not be a well-formed formula because it's supposed to have something on this side, and yet it's missing. Any other questions? Yeah, go ahead.
Alpha contains all the tuples as well, right? Like you could have a tuple of like individual elements in alpha.
Alpha does not have any tuples, or at least not in this particular propositional logic system. So in this particular case, I only have these symbols. But at this point, there's no meaning associated with 0, 1 yet. Okay? 0 doesn't mean false. 1 does not mean true. They're really just literally symbols. Okay? So are there any questions regarding what is the set of alpha, and what is the set omega, and what is a WFF, a well-formed formula? There's no meaning whatsoever at this point. They're nothing more than just symbols, and symbols that can connect to become bigger symbols. But what they mean, we don't know. They have no meaning at this point. Is that okay? So this is very, very mechanical. It's just Lego blocks, okay? What kind of Lego block can connect to what kind of other Lego blocks? That's it. But are we making a car? We don't know. What is that thing? Well, we don't know what that thing is. We just know that it is a well-formed formula. Are we still doing okay so far? Okay. So if I make this a actual well-formed formula like this, okay, that becomes a well-formed formula because now the implication has a well-formed formula on one side and a well-formed formula on the other side. It is now a well-formed formula. Is that true or false? Nope, I don't know. Don't ask me. I have no idea. Because I have not defined iota yet. Okay? So what is iota? Yep, the semantics. It's called the semantics. So when you look through the notes here, okay, so they're the initial points or the axioms. I can define the iota to be 1, okay? If 1 is an element of the iota, that means 1 is by definition true. In other words, iota consists of everything that is known to be true by definition. Don't ask me why those things are true, because they're just by definition true. So what I do here is I say 1 is true. So instead of spelling out true to be true, I now choose to use the simple 1 to mean true. Well, I want 0 to mean false, but yet I cannot say what is false. But anything that is not false is true. So if I say the negation of 0 is true, I'm also basically saying 0 itself is false. Are we still doing okay so far with the first two items? The third item is the negation of 0 and 0. What does that mean? If the negation of 0 and 0 is true, what is 0 and 0? 0 and 0 is by definition false. Okay? In other words, I just spell out the truth tables. I spell the truth table for and, conjunction. I spell the truth table of or, and so on. Those become the foundation, the lowest layer of actual meaning in this logic system. Are we still doing okay so far with what is in iota? Why the iota set is important? Because without the iota set, I don't even know what is true or false. It defines the most basic terms. Yep.
So the first one is what you're defining, and everything else is like you're showing that it's one.
Okay. Well, how about this? Each element is definitely a well-formed formula. Okay, because we can only refer to well-formed formula when we say, okay, is that true or not? This is a set of well-formed formulae that are by definition true. In other words, there's no reasoning. Don't ask me why they are true. They're just by definition true. Okay, so these are the well-formed formulae that are by definition known to be true. So I define in doing this part. Okay, let me just point out which part here. This part here is basically the meaning of conjunction, because I spell out, in a conjunction, all the possibilities of combining the left-hand side and the right-hand side, and which one is true and which one is not true, which one is false. So I'm basically defining all of these operators in terms of linking the operators to true-false values.
Is all the stuff represented by the dot or the ellipses, is that like ors and stuff like that?
Yeah. Yeah, so the or is going to have, okay, the mosquito is after me.
What, you're afraid to get the Zika virus?
No, I just don't like to be itchy. And I'm going to be here for another 2 hours or so it's not a comforting thought. I think next time I'll bring my bucket of salt. Yeah. And it's going to go after me because I'm the one who's walking around, so I'm emitting a lot of carbon dioxide. And that's how it can home into me, is because of the carbon dioxide gradient in atmosphere.
You need to crank up the AC.
No, I need you guys to breathe out more carbon dioxide. The AC won't help until it gets down to like maybe 50 degrees, then the mosquito cannot fly anymore, then I was sick. Okay, so basically that's one part of it. Okay, but somebody asked about the dot dot dot, and the answer is yes. The dot 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 basically would include the truth table of or, disjunction, the truth table of not. Okay, I have, well, actually not is already here because the 1 and the not 0, that defines what a not is. And then we also have, let's see, what else? Yep. No, De Morgan's law is a transformation. It is a little bit different. Okay, these are basically things that are by definition to be true or false. Okay? But there's something else to be here. In addition to, these are basically what we call, the portion that I have already included here. These are the axiomatic definitions. Okay, they're basically just axiom. Don't ask me why, but this is how things are supposed to be defined. But I would also include specific facts from which logical conclusions can be drawn. In other words, if I just give you this stuff here and only give you, the PQR, psi, phi, and rho, and stuff like that, it doesn't do any good, right? Because, okay, so how do we use this system? Well, it's not useful. So what we need is our facts, okay? What we need are facts that we are trying to model. All right, so here's an example. This is actually a paragraph that I added today, so you may not have read this part if you have read it like earlier. So we'll define P as Tech drinks coffee. Tech drinks coffee is just a statement. It's a condition. It is not an assertion. It is not describing what I'm doing. It is simply a condition. Because it can be true, it can be false. Is that okay? But I just label it P because otherwise I would have to repeat the sentence or the phrase several times. And then we define Q as tag is sleepy. Once again, it is not an assertion. It is not a fact. It is simply a condition. It is just, it can be true, it can be false. And that's why it is a variable, because it can be true or false. It is a variable. Are we doing okay so far with these two? Yep.
One of the things you said about that the iota is not it's the well-formed formula is meaningless without iota. But then iota uses well-formed formulas inside of it.
Yes.
So they use each other?
Okay, well-formed formula is not in any of the sets that defines a propositional calculus system. The alphabet, alpha, gives you the basic building blocks. Okay, syntactically, these are the most basic building blocks. Kind of like what you can type on the keyboard. Okay, the connectives tells you how you can make bigger things, how you can string elements from alpha to become bigger and bigger and bigger things, and they're structured. But these things have no meanings whatsoever. It simply says you can make this, and it is called a well-formed formula. What does it mean? I don't know. Is it true? I don't know either. Okay, so at this point, conjunction does not really mean conjunction. It literally just means two lines making this shape, but has no meaning whatsoever associated with it. It's just a symbol. Okay, and we know that in order to make a well-formed formula out of the conjunction, you need a well-formed formula on one side, you need another one on the other side, and then the whole thing can now be considered as a well-formed formula. But what does it mean? We don't know. There's no definition yet. Are we doing okay so far? Yeah.
So now, basically, for this paragraph, you've actually assigned like a statement for like one of the alphas, basically.
Yeah, we are actually doing two things. The first thing, if you look at the top of the screen right now, the top part here, these are axiomatic definitions, okay? And these things give meaning to conjunction, disjunction, implication, negation, and is equivalent to. So those symbols now have quote-unquote meanings, because now I can look at this thing and say, well, if you can tell me what is the left-hand side and what is the right-hand side, I can tell you whether this conjunction is true or false. Okay? But before I define iota, you can't even do that. Is that okay? But we can also do a little more, getting back to the PQR. So in this case, PQR are stating basically facts. They can be used to state facts, but I can use P to represent tag drinks coffee. Whether P is true or not is a whole different question. It is simply a shorthand of tag drinks coffee. It can be true or false. It is a variable. And then Q is defined kind of similarly. It's just tag is sleepy, can be also true, can be true or false. R is defined to be tag has more work to do. Once again, it can be true or false. So all of these things are variables, and that's why I choose to use the symbols P, Q, R instead of the Greek symbols, because the Greek symbols, the purpose of the Greek symbols is they can be constants, they can be variables, they can be any well-formed formula. It's a wild card, okay? Both of these are wild cards, but this can only be a wild card of constants. The P, Q, R can only be wild cards of constants. The Greek letters are wild cards of well-formed formulae, and that's why in this case I should not be using the Greek letters. Okay. Now the iota can now contain this particular item. Okay. First of all, the iota can go ahead.
So this is like tag drinks coffee. That's in the C++, for example, that they do the same rule. Tag drinks coffee equals 0 or 1. That's what.
Not equal. It's just a variable. It doesn't have any particular value.
So it's the variable part itself in that.
At this point, looking at this paragraph, you can just look at PQR as shorthands of Tech drinks coffee, Tech is sleepy, or Tech has more work to do. They're just shorthands. We don't know whether Tech really is drinking coffee or not, whether Tech is sleepy or not, or whether Tech actually has more work to do or not. They're just shorthands. They're just representing, the Boolean values that is behind the scene.
So basically the variable name.
They're variable names, yes. And instead of typing a whole lot of letters, we're just typing P, Q, and R. Okay? Now, what I have highlighted here on the projector, that is a part of Iota. But before we can say it is a part of Iota, we have to make sure it is a well-formed formula, right? Do we know whether this is a well-formed formula? Okay, so we look at the connectives, right? Because the connectives is kind of the top level. We look at this connective and say, do we have a well-formed formula on the left-hand side? Well, we have a variable on the left-hand side, but all variables are from alpha, and everything from alpha is already a well-formed formula. So that's good. And then on the other side, we have a conjunction. So with this conjunction, we look at the conjunction connective operator and ask, does it have well-formed formula on both the left-hand side and the right-hand side? And the answer is yes, because Q is in alpha, R is also in alpha. In other words, this entire thing is also a well-formed formula. So that makes the equivalent to expression, which is this entire thing, also a well-formed formula. In other words, it is eligible to be in Iota. Yep.
Doesn't the Iota have to be true?
Yes. So basically, when I put this formula into Iota, I'm saying Tech drinks coffee if and only if he is sleepy and has more work to do. And. This is an and. So I don't drink coffee because I have to play another round of League of Legends. That's Mountain Dew.
Jack?
Yes.
So, I'm not sure if this is reiterating what you just said.
Go ahead.
So if we have a well-formed formula that you have highlighted, tactically it's correct, but can it also not be true?
No, this has to be true. In order for something to be in Iota, it is by definition true in the universe that this system is trying to model.
But you said it's regardless that we don't know if Tack drinks coffee, so let's change that to poison. Tack drinks poison.
Hold on a second here. Okay. It's not that, everything is poisonous because we all die in the end, right? So you can say everything is poisonous like that. Okay. If you don't drink anything, don't eat anything, you die even faster. Okay, so this itself is true, okay? But it's an expression. How do you make this entire expression true? It locks down certain combinations of P, Q, and R that makes it true. And that determines, this is modeling the world of Jack drinking coffee. Is that okay?
I'm just having a little trouble wrapping my head around. Let P represent Tack drinks coffee.
Yes.
It doesn't matter if you drink coffee, it can be anything.
Well,
That
if
is
Q,
true.
if
Right.
Q is false, then P is false. We're not saying that anything up there particularly is true.
Aha.
We're just saying
Yes.
that statement is true.
Yep, exactly. Go ahead.
So, if you just have work to do, then you're not gonna necessarily drink coffee.
Necessary.
Because you have to also be sleepy at the same time in order to drink coffee.
Aha.
Right?
I have to be both to be drinking coffee, yes.
So you can be sleepy but no work to do and you're not gonna drink
That
coffee.
is correct. Okay, so let's look at this in a slightly different way, okay? Because I do want to make sure that you guys understand what does it mean when a particular expression is in Iota, okay? Because what does it mean? Because you can understand, when P itself is in Iota, that means Tech is always drinking coffee because it's always true. That would be awful. Okay, as much as I like coffee, I don't want to be drinking coffee all the time.
Isn't it right there?
Okay?
Could be a horrible way
It is
to
that,
live.
but I'm not drinking that. Right? And who said that's coffee, right? But P itself is a variable, can be true or false. Because it's not in iota, I did not put P itself in iota. I did not put Q in iota. I did not put R in iota. I put this expression in iota, which means this expression is guaranteed to be true. Attack may not be drinking coffee. He may not be sleepy. He may not have more work to do. So what is this really saying about this world? Let's do a truth table. This will help you understand, what does it mean when something is in iota? P, Q, R. 3 independent variables. How many rows are we going to end up with in the truth table? 2 to the power of 3 is 8. Okay. So 0. Oh, that doesn't work. That's even worse. Let's see. Yeah, maybe. Was it this class I was telling someone to make a rechargeable whiteboard marker?
Refillable.
Yeah, refillable.
They do those, yeah.
They do?
Yeah.
I think this campus really should use some, and we can have a little refill station right here, just so.
Not that fancy.
They're not automatic
Huh?
though. You have to like use a dropper thing.
Yeah.
A dropper? Are you? Huh?
There's ones that are like cartridges.
Cartridges. Or maybe there's a little, a fill setting here, a fill fixture. You can just kind of plug it in and it pressurizes and it will automatically fill. And it will stop based on the weight of the item because then it knows whether, it has enough.
Or it can gauge back pressure.
Sorry?
Or it could gauge back pressure.
But these
That way
things
it
are
doesn't blow.
inherently leaky. So if you rely on back pressure, it will just be oozing out the ends. That will not be.
Unless it was pressurized at the tip for when you press down, then it doesn't.
Yeah, possibly. But I think we can use that recharging thing. Okay. P can be true, P can be false. Okay? So I can be drinking coffee or I can be not drinking coffee. Okay. But while I'm not drinking coffee, I can be, what is the next one? Sleepy. Sleepy, not sleepy, or sleepy. When I'm drinking coffee, I can be not sleepy or sleepy. And then on R, I can be not have more work to do, have more work to do, and so on. So now I have 8 unique ways of combining P, Q, and R, each one being a binary or Boolean value. But we do okay so far with setting up the 8 combinations of zeros and ones, true, falses. Okay. So now we look at the expression. The expression is P is equivalent to Q and R. Now we say, okay, is the expression true when they're all false? Yeah. Yep, the answer is yes, it is true. Okay, we put a 1 here. Okay. Are there any questions about why this is true when they're all false? What is the truth table of is equivalent to? Do you guys remember? Okay, I'll just quickly go over that, but you should read the notes, okay, because that's actually important. So if you have x, y, and then you have x is equivalent to y, okay, so this time we have 4 items, 0, 0, 1, 1, 0, 1, 0, 1. This is a 1, this is a 1, those are all zeros. That's the definition of is equivalent to. So when you have P being 0, Q and R are both zeros, then you have 0 is equivalent to 0. It is true, not a problem. Next row, gotta be true again. True again. This one is false. The 4th one is false because P is false, but both Q and R are true. Q is true, R is true, true and true is true. So now we have false is equivalent to true. The expression itself is false. Are we doing okay so far? I'm really just applying, the truth tables and by definition what we do with these operators. This one is false because we have a 1 on one side. This one is false. That one is false. This one is true. Okay. So now that we have a truth table already defined, then we are basically saying, in this particular world, okay, according to this particular propositional logic system, okay, only these combinations can happen. The other four are impossible. Are we doing okay so far? If you observe tag at any moment in this particular universe, you can observe tag, there are four states that tag can be possibly in. 1, 2, 3, 4. What exactly are those four states? Tag is not drinking coffee, is not sleepy, and it doesn't have more work to do. Tag is not drinking coffee, is not sleepy, it does have more work to do. But not sleepy, don't need the coffee. He's not drinking coffee, sleepy, but doesn't have more work to do. This one is not possible. Okay? Because by definition, it is not possible. If I put the expression itself into iota, it means the expression itself has to be true. So that means these four possible combinations are impossible. You will never observe me, for instance, in this state. I am drinking coffee, not sleeping, but has more work to do. You will never observe me in that state. Are we doing okay so far? The last one, once again, is possible. I am drinking coffee, I am sleepy, and I got more work to do. But it's the meaning that I want to make sure that you guys understand is what does it mean when a well-formed formula is in iota. Are we doing okay so far? Because the other ones we can kind of understand. These guys are easy, okay? Because we are just defining one to be true. Okay, good. In this one, we are defining not 0 to be true. Okay, we can understand that one. This one is defining not false and false is true. We can understand when it is only constants. And by definition, using the operators, those are the true false values. Those we can easily understand. This one is a little bit harder to understand because I never really put P, Q, or R into iota. The variables are not in iota by themselves, but the expression is, because the expression is specifying a rule. Okay? Now, in this world, in this particular universe that is modeled by this logic system, it's a very simple world. Okay? But nonetheless, this is the rule that dictates what happens in this world. Are we still doing okay so far with this analogy? It's an example. Yep.
Is there significance why you chose Q for the table?
Say that again?
Is there a significance why you use Q for the table? Like, could you have used RP?
Which table?
The one up there on the board where you say Q is true, true, true. Or
This one?
Yeah.
Because I have already defined what P, Q, and R mean over here.
No, I think he's saying it's just underneath the entirety of the statement. It's not
Oh, that's the
particular.
entire statement.
Yeah, it's not particular to Q.
Q is comply with your Q.
Oh, okay.
Okay, so it's the whole thing.
The whole thing, yes. Okay, so are we still doing okay so far? So here comes the next question. The next question is, okay, so if I include specific facts, in other words, if I also put Q into iota, and I put not P into iota, okay? In other words, this time I am asserting that tag is sleepy, but I'm also asserting that tag is not drinking coffee. It does not drink coffee, okay? What can you deduce? That is what propositional logic is really for. It's for deduction. It's not really just for recording stuff, okay? But it's for deduction. What can you deduce when it is already known that tag is sleepy and tag is not drinking coffee? Can you deduce anything?
Tag is asleep.
You have no more work.
Exactly. I do not have any more. I don't have any more work.
Yes. It's pretty much those first four statements.
Okay.
Right?
Yes, because you just find the combination. Because if I give you 83 out of the 4 on each row, you can locate what is the missing value. Well, not all the time, but with this one, yes, you can. Okay. So it's about deducing, it's about deduction. If I tell you the rules, I tell you a few facts, can you deduce the rest? That is what the propositional logic system is for. Yep.
What if it's not possible to deduce the fact? What if it's not possible to deduce the fact? Let's say
Then you cannot prove it. Then it is not established as something that always has to be true. Okay. All right. So now we have almost everything here. What we are lacking is zeta. Zeta is a rule, the transformation rules, okay? So at this point we have defined the language itself, we have defined what is true and what is not true, okay? At least the basic stuff by definition. But we haven't really talked about, okay, how do we transform from one form to another form? So basically each element of zeta is going to be like this. It consists of one set on the left-hand side, and then we have that kind of weird, kind of rotated T symbol. And then on the other side, we have, something else. We have the result of the transformation. Are we doing okay so far? Okay. The most important part is it is a set on the left-hand side, but it's a single well-formed formula on the right-hand side. So what this means is if you can find a certain format of well-formed formulae in the set that is known to be true, then you can also deduce that this well-formed formula is also true. Yep?
What does the T, the rotated T sign mean? In between the set and well-formed.
You mean this one here?
Yeah.
I think I might have mentioned it here.
Did you say it meant infer yesterday?
Sorry?
You said it meant infer yesterday?
Infer, yeah.
Infer?
Oh, yeah.
Yep, it infers. So the left-hand side infers the right-hand side.
Okay, thank you.
And each one is also called an inference rule because it does inferencing. Okay, but this looks really abstract. Let's look at certain examples. So in propositional logic, okay, in a logic system, this is one particular rule. Okay, let's just take a look at this one here. Try to highlight the portion that I want to highlight. There we go. Okay. What does that mean? It means an empty set, because there's nothing to the left-hand side, it is implied to be just the empty set. So the empty set, without knowing anything to be true, I now infer that any well-formed formula or the negation of the same well-formed formula is true. Does that make sense?
Because you have no information from the set. It's a null set.
I don't need anything. I don't need to know anything in order for me to say that any well-formed formula or the negation of the well-formed formula that I have just said, the disjunction has to be true. Does that make any sense?
Yeah.
It does, because if the well-formed formula itself can either be true or false, right? Let's say it's true. Well, if the well-formed formula itself is already true, I don't need to know the other side, because in a disjunction, you need only one side to be true for the entire thing to be true. Okay, fine. What if the well-formed formula, in this case using the psi symbol, is false? Okay, if that is false, the negation of that has to be true. In other words, when I look at the two sides of the disjunction, one of them has to be true. And as a result, the disjunction has to be true as well. Is that okay? You might think, oh, but this is a useless rule. Why would anyone, put this rule into the system? Well, it actually turns out to be handy sometimes. This one is also true. Okay, this one is basically flipping the disjunction into a conjunction and say that any well-formed formula and the negation of the same well-formed formula has to be false. That's basically what it's saying. Well, that makes sense because just like what we said earlier, at least one of the two sides has to be true, we can also say at least one of the two sides has to be false. But if one side is false already, then the conjunction is guaranteed to be false. If the conjunction itself is false, then the negation of that is guaranteed to be true. This one is famous, and that's why it has got its own name. This one basically says if, okay, given two things, okay, these two things, they both have to be true already. We have phi, okay, phi is known to be true, and then we have phi implies psi to be true. If these two are both true, then we also know automatically that psi also has to be true. Okay, well that's basically how we use implication in daily life. Okay, and this in return, will be useful for a lot of different proofs because it basically allows you to use deduction in this manner. This one is also useful. It looks kind of in some way similar to the other one. In some way, it is kind of like the flip side of the other one. So let's take a look at this one. It says right here that we have the same implication. Remember, in a set, the order does not matter. Okay, so I'm just going to talk about the implication first. It says right here that phi implies psi. Okay, just like before. But this time, I'm not telling you whether phi itself is true or false. I'm telling you that psi is not true. Okay, but what can I deduce? What has to be true as a result of this? In this case, I know the negation of phi has to be true. So it's kind of like the previous one, except this is the opposite. Can anyone guess, what type of proof or what type of proof technique is the result of this particular rule? Proof by contradiction. Yep, exactly. Very good. This one is kind of trivial in a way. Because it says, if you already know that phi is in the set of true well-formed formulae, and psi is also in the set of true well-formed formulae, then the conjunction of these two is also true. Well, that's kind of a no-brainer. The next one is not as much of a no-brainer. Even though it looks simpler, it is not as much of a no-brainer. The last one, at least up to this point, is basically saying if I tell you that phi and psi is true, that expression itself is true, what can you deduce? What can you infer?
The first one has to be true. Otherwise you don't.
Actually, either one can be true. Either one has to be true, actually. But you can simplify. Okay? So this one doesn't seem like, oh, but why would this be useful? Because it's useful for simplification. People who are also taking 310 probably will understand it. Like, yeah, that's going to be useful. Yep.
So you just randomly pick the first consonant?
Correct, because I have other rules down there. Now these ones, okay, everything from here all the way down to here, you can see that the infer symbol only goes one way. Okay, given the set can be an empty set on the left-hand side, the right-hand side can be inferred. Only goes one way. It doesn't go the other way around. Okay? I'll give you one example. Just look at the last one. Okay? If I tell you that phi itself is true, I cannot conclude that phi and psi is true as well. That's not possible. So at this point, it's only going one way. But what about those things like the commutative rule, distributive rule, De Morgan's law, that sort of thing? They go in both directions. And because they go in both directions, I'm going to use a slightly different symbol here. Okay? So it's this one here, look at this one here. It's kind of like having two inference symbols, but they're pointing each other. Okay? But that's exactly what it is. And you also notice that instead of having a set of well-formed formulae on one side, both sides only have a single well-formed formula. Okay? There's no set anymore in this case. But let's take a look at these rules. Okay. The first one is just implication. And it, yeah, go ahead.
So just a side question. Looks like an example that makes a difference between imply and infer.
Okay, that's a good question. What is the difference between imply and infer? One is syntactical. Infer is syntactical. It is nothing more than manipulating the symbol. It simply says, if you see this pattern, you can replace, or if you see these well-formed formulae being true, syntactically, you know that this one also has to be true. That's what it's saying. In this case, we can basically say, if you see there are two well-formed formulae, you see that the negation of one or the other one is true, then you can syntactically transform that into another well-formed formula that also has to be true, which is the first one implies the second. But it's all syntactical. It's nothing, there's no meaning associated with it. When we use the word implies, it is a semantics. Then we actually associate true-false values. Okay, so when you go down this list, there's a whole lot of kind of not so exciting stuff here. Like this one is not very exciting, it's just commutative. This one is also just commutative. One is for conjunction, the other one is for disjunction. And then we have associativity, left associative versus right associative. And then we have double negation, it's just right here. And then we have distributive, but in Boolean algebra, there are two distributive law, because you can distribute conjunction over disjunction and vice versa. Yep.
Shouldn't your associative law of conjunction would be disjunction?
Well, that's clearly a copy and paste mistake. Huh? Copy and paste, and then forget to modify. Okay, thank you. Good job pointing it out. Okay, so these are basically transformation rules. Are there any questions about everything up to this point? Okay, if I were to ask you a question, can I specify a propositional logic system that actually does not make sense in real world? Absolutely, okay? Because these are nothing more than just rules that specifies, oh, if you see this and that, okay, then that, is the result, okay? But does it really match anything that's real? We don't know, okay? It's just syntactical. But why would we talk about something like that? It's completely symbolic manipulation. May or may not have anything to do with actual law in real world. Why would we talk about something like that? Sounds like a completely abstract mathematical exercise for no particular reason, but to take up a few hours of this class. Yep.
Because we have to have a concrete basis to start from.
Well, yes and no. But let me ask you this question: what is a computer? What does it do? It do calculations and whatnot, right? It can also do symbolic manipulation. Okay. The simplest one would be, editor. You can do a search and replace. Okay, purely symbolic manipulation. Can your computer check whether it makes sense or not? The word that you specify to replace with and its replacement, does it make sense? Does your word processor tell you, hey, it doesn't make any sense to replace this word with that word?
They try, but it messes up all the time.
Sometimes, but usually not.
No, it does not.
Yeah, that's what
It does not, because it's a purely symbolic manipulation. Your computer is good at that. Are we doing okay so far with that?
If you're using Google sometimes, did you mean?
And many times I have to say, no, just keep the original search. Yes.
You do what I told you.
Okay? But that's exactly why. We are specifying, up to this point, we are specifying things that we can ask computers to do. Pattern matching. Okay? See this pattern here? See this pattern? See this pattern? Oh, that pattern has to be true too. Or that pattern has to be, is the result of seeing these things. Okay? Computers are very good at that. Well, if you specify the wrong rules, then the wrong things will come out. Okay? It doesn't make sense anymore. So the next question, or I'm not going to have enough time to go through all of that tonight. But what we'll talk about on Tuesday is going to be the soundness and the completeness of a propositional logic system. That is connecting all the grammatical, mechanical stuff that we have been talking about to the actual logic system that makes sense to us. So the question is it sound? Sound means it makes sense, okay? Is it complete? Complete means it can represent everything that you can normally represent using the logic system. So everything that we normally do by hand, can we do all of that in propositional logic? That is completeness. So we want to make sure that both of these requirements are both satisfied in order for the propositional logic system to be useful. Are we kind of doing okay so far? Because I just took a step back and look back and say, okay, let's forget about all the symbols, the truth tables, and whatnot. Why do we even talk about this? Because we want computers to be able to do certain types of reasoning for us, such as proving mathematical theorems and that sort of thing. And this is the basis, okay? It's not the Holy Grail, this is far from the Holy Grail, but it is the introduction. This is a step in that direction. Okay? So I'm running out of time for 440. I will continue on this, so continue read the notes ahead of me, and then on Tuesday we'll talk about this. By the way, no class on Friday and no class on Monday.
You mean we're not meeting up on Friday?
We're not meeting on Friday. And no class on Monday. I know some of you probably have Monday classes.
I have class Friday and Monday, so that's nice.
You do?
Yeah, but luckily I only have work on Friday, not Monday. So